This is part 2 of the video predicting products, and we left off with decomposition. Just one more type. Acids. Some acids will decompose and break apart into a nonmetal oxide, which is just, you'll see, the nonmetal with oxygen, and then water. So these, like carbonic acid, remember carbonic came from carbonate, which is -2, so we would need 2 hydrogens. And then decomposes. And then the nonmetal oxide is just going to be, well, let me do the water first, actually. So if you do the water, you can see that we used up an O here. So then that would make this only have 2 oxygens. So that's how you can figure out the nonmetal oxide. You can't do that one like by balancing charge. So you're just going to make sure when we do these that your elements are balanced. Normally we don't do that, we balance it after, but for these, the only way to predict the products is to do that. So let's do another, and at any point you should pause me and then try and then see how you do. This one is sulfurous, so that comes from sulfite, which is -2, and that's, why we have 2 hydrogens. And again, I like to do the water first, or doesn't matter what order, but then I know that my nonmetal oxide will be 1 less oxygen because one of them went into the water. So that's it for decomposition. Now we're going to talk about single replacement. And there's an activity series in your book on page 286. And how you use this is the metal that single replacements, most of them, there's some where it's a little different, but so you have this lonely metal going in and kicking out the other metal. It has to be the metal or the cation. And then that forms a new compound and a new lonely metal. This metal that goes in has to be higher in the series, which means it's more reactive. If it's lower, it's not going to happen. The reaction just won't happen. So you can see, like lithium is the king of the metals, so most reactive, can replace any of these underneath it. You can see our valuable metals like silver, platinum, gold, those are down here. They're very unreactive. That's why we like them. We like to make them into jewelry and other things because they're not going to all of a sudden go, wait, I'm going to go react and form a new compound. So you want to make sure the metal that's by itself is higher than the one in the compound, and then you know it will happen, and then you can go ahead and predict the products. So here's an example. So lithium metal, and it's a solid, and then magnesium chloride. Magnesium is +2, it's in group 2. Chloride is -1, it's in group 17. Normally I wouldn't make you come up with that aqueous, but for these reactions to happen, the compound has to be aqueous so that the lithium can go in and kick out that magnesium. Lithium is higher than magnesium, so this reaction will happen. So that's going to make our new lonely guy. Remember, lithium's lonely. Now magnesium is. And when this happens, this will be a solid, because all metals are solid at room temp except for mercury is a liquid. And then the lithium is going to be with the chloride. But here's where you do have to balance charge. It's a new compound. So you have to, this is my thinking bubble up here. So I'm thinking this, I don't have to show it, but I know that lithium's +1, chloride is -1. So they're just going to be in a 1-to-1 ratio. Remember the diatomic part, just so you know, this happens to be 2 because magnesium was +2, not because it's diatomic. It's only when it's all by itself that it has to be. So then I would balance, I would need a 2 here to balance the chlorine, and then a 2 here to balance the lithium. Let's do another. So this one's solid copper. We're going to do a lab with kind of something like this too. And reacts with sodium chloride. And again, this has to be aqueous. So then we want to look up over here and we find our copper. Where is he? Hiding. Can't find it. Here's copper. And then sodium's up here. So this is not going to work. The copper has to be higher in that series and more reactive than the sodium, and it's not. So we would just write no reactions. That one's easy. We don't have to balance it or do anything. Also, the halogens, group 17, they can also replace one another. So let me show you. I've got this reaction here. So fluorine is going to react with sodium chloride. And then you have to realize this is a nonmetal, so it's going to take out the nonmetal part now. So my lonely guy, sometimes I say my lonely girl, make the nonmetals girls, is going to replace this nonmetal. And then you have to check if it's going to happen. Again, it works the same way. Fluorine's more reactive than chlorine, so this will happen. So now we have a new lonely girl, nonmetal, and we have a new compound. Remember when we write compounds, the metal goes first, nonmetal goes second. My thinking bubble here is I know sodium's plus, I know fluoride's minus, and then there's one other thing I'm forgetting, so think about that. Don't forget this guy when it's our girl, because we're making the nonmetals girls. She is diatomic, part of that. So you're never going to find a chlorine alone. So if it can't bond then into another element, then it will just be in a pair. So, and then you would balance. We love balancing. These are nice and easy. And we're done. So now we're going to talk about one of the last types. So double replacement reactions. These are going to happen. You'll have a compound and compound, and then you make two new compounds. So it's kind of like, whoops, I just made AB, making the wrong letters, CD. So then you would end up with AD and CB. So this is kind of like switching partners. Like if you were dancing in Phi-Ed, maybe you danced and you would, at least I did, we square danced and then we would switch partners. So when a double replacement reaction actually happens, you guys, when we were doing the ion lab where we would add the drops, you know, drop, 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 some of those didn't happen and we didn't see anything. So the three reasons why a double replacement reaction will happen is one, you form a precipitate, which is what we were looking for in that ion lab, or you form a gas, or you form water. So these are the three reasons. Otherwise, they don't happen. Unlike the single replacement, we're not going to worry about that right now. We're just going to write them as if they all happen. But, you know, if we had more time, you can actually figure out whether they will react before you even put them together. So here's an example. Silver nitrate plus potassium chromate. So silver is +1, nitrate's -1. These always have to be aqueous, by the way. In order to react, they have to be ions in the solutions. Here we've got potassium chromate. Potassium's +1, chromate is -2. Those are on my pink sheet. This is also aqueous. Let's not worry about those right now, though, actually. So then, in order for us to predict, we're not going to predict whether it happens. We're just going to assume it does. The silver is going to go and be with the chromate, and the potassium is going to go and be with the nitrate. So up here's my thinking bubble. Potassium is going to go with the nitrate. I didn't bring the 2 with, because that 2 was there to balance charge. So my new compound is KNO3. And then the silver is going to go with the chromate. And then to balance charge, it'll be Ag2CrO4. And then we can balance the equation. And that is it. Let me see what I got next. Combustion reactions are when you have a hydrocarbon. So it's always going to be carbon, hydrogen, maybe oxygen. And then in order for something to burn, you know how we fan the flames? It needs oxygen. And then the weird thing is that when you're burning something, I always think this is strange, like during wildfires, we're forming carbon dioxide and water, and both of those will put a fire out, but not in the gas form. So if this was a liquid, yay, it would put the fire out. And if this were a solid, yay, it would put but they're both gases. But let me show you. So if I were going to do this combustion, if I know it's combustion, it's just automatic pilot. This guy goes here. That one is going to change, but these three don't. So you don't have to balance charge or anything. You just have to remember, and put it in your notes so you have it. Remember when we balance these, we'll balance this one for fun. We always go in the order of CHO. So I'm going to balance my carbon first with a 5. Then I'm going to balance my hydrogen with a 5. Then I'm going to count my oxygen. You can see I have 10 plus 5. I have 15 oxygens. So that's where I can use that fraction, 15 halves. I can leave it like that, or I could multiply the whole thing by 2. This would become a 2, a 15, a 10, and a 10. That's all I have.